Hello participants, welcome to this session on linear regression. In the previous sessions in this module, we discussed about the role of statistics in machine learning. We understood what it is and what kind of role it is being played. We also looked at the types of machine learning algorithms, which spoke about supervised, unsupervised, and reinforcement learning. And we also looked at how algorithms can be categorized in different ways. Now, we will focus on popular algorithms which are in machine learning space. We will start with the basic one, but one of the most powerful ones, linear regression. So what is linear regression? Right from our childhood days, we would have heard of this, we would have applied it in our class, in mathematics class. But yes, we would not have realized that, okay, this is the concept that's going to help us to create a prediction machine. So let's understand what is linear regression. So this comes under the supervised learning approach to begin with. And the focus of supervised learning revolves around the input and the output variables using the algorithm to predict the outcome if a new input variable comes into picture. So this is what we have been defining as supervised learning approach so far, right? The machine learning, when we discussed some examples, this is what we understood as the machine learning. Now slowly you would have understood that it is supervised learning approach. And now slowly if you can realize that it is linear regression that we have been talking for a long time. The linear regression algorithm in machine learning is a supervised learning technique to approximate the mapping function to get the best predictions. What do you mean by mapping function here? So what we are trying to map here is the relationship between the input and the output variable in the historical data. What kind of relationship that exists between the input variables and the output variables? Can you define it in the form of an equation? If you are able to do that with a generic algorithm like linear regression, that is what is called as a machine learning. So what is regression? The main goal of regression is the construction of an efficient model to predict the dependent attributes from a bunch of attribute variables. That is, you are trying to predict something y with the help of the independent variables that are available. We call it as attribute variables or independent variables, which are nothing but x1, x2, x3, the number of variables that you need to correctly predict y. That's why we write the equation as y is equal to f of x. A regression problem is when an output variable is either real or a continuous variable. Like for example, salary, weight, area. So here I would like to request you to understand two broad types of variables: categorical and continuous. What is categorical? It is either or, 0, 1, yes, no. That is a categorical variable. Continuous variable is something which stays between 0 and 1, which can have a number. Like for example, salary. It can be any number, right? You can't put it as either or. Weight. You can't put it as either or. You have to give it like 50 kgs, 70 kgs, 90 kgs. There will be a number associated with it. Area in the same way, like 500 square feet, 700 square feet, you can mention it in the form of number, a continuous variable. So regression helps you to identify that continuous value. It is able to predict that continuous value from the set of independent variables which are going in as input. So regression is used to predict the relationship between a dependent variable and a bunch of independent variables. Y is equal to f of x means y is the dependent variable, x1, x2, x3, the number of variables that you want have it on x part, that is nothing but the independent variables. Let's understand this with an example. The best way to understand the linear regression is to relive the experience of the childhood. Let us say you ask a child in the 5th grade to arrange the people in his class by increasing order of weight without asking the students what their weight is. Is it easy or tough, the problem? A bit challenging, right? But the child will be able to do it very easily. He or she would likely look, that is visually analyze, the height and the build of the people, and slowly the child will arrange using a combination of these visible parameters, that is the height and the build. If the child is able to arrange all of them in the right order, that is called as the linear regression. The child has actually figured out that the height and the build would be correlated to the weight by a relationship, which looks like the equation above. Okay, so this is something you need to understand. So how will the equation look like? This is how it will look like. The equation will be y is equal to ax plus b. Okay, where y is the dependent variable, a is the slope, that is nothing but the weight we generally call it as, x is the independent variable, and b is the intercept. These coefficients a and b are actually derived based on minimizing the sum of squared difference of the distance between data points and the regression line. So we try to draw a best fit line. Now I'll slowly connect the dots with the concepts that we have already studied. Remember, Ada Lovelace mentioned that everything is math. Everything in this world can be seen in the form of mathematics. You can fit them in the graph, and when you have the data plotted in the graph, you can always solve the problem with the help of an algorithm. Same way, the height and the weight, you are just plotting them, and you are trying to draw a best fit line there. So this best fit line, how do you find whether it is a best fit or not? When so many lines can be drawn connecting all these variables, how do you find out what would be the right fit for the line which is going to pass across most of these variables? This is where you are trying to come up with this concept of minimizing the sum of squared difference of the distance. What is the distance between the line and the data point? And square the difference of the distance between the data points and the regression line. So when you square it, it becomes a positive number. Can you minimize this total number that comes in? If you're able to do that, then you have got the best fit line. So here we have identified the best fit line as y is equal to 0.2811x plus 13.9. Now using this equation, we can actually find the weight knowing the height of the person. That is, weight is equal to y, x is equal to height. So if you know the height of the person, you can compute the weight of the person with the help of this equation. This is how you solve linear regression problems. So linear regression can be broadly put under two types: simple linear regression and multiple linear regression. So simple linear regression is characterized by only one independent variable, that is f of x is nothing but f of x1, that's all. Multiple linear regression, as the name clearly suggests, it is characterized by multiple, more than one independent variables. That is x1, x2, x3, x4. You can have multiple number of variables depending on the problem statement that you have. Like for example, in the previous slide, you saw something like based on the height you are predicting the weight. There is only one variable. So you call it as a simple linear regression. But if you want to predict the temperature of the day and the independent variables you are considering, like whether it is going to rain or not, humidity, all these factors when you are going to consider, these are multiple variables coming into picture to predict that y, which is nothing but the temperature of the day. Now for this, you need a multiple linear regression. So while finding the best fit line, you can always fit a polynomial or a curvilinear regression. These are known as the polynomial or the curvilinear regression. So don't worry if you're not able to understand the technical aspects of these things. It's okay. As a student, it's fine to understand this aspect. But now with this basic definition of linear regression, can we understand the advantage and the disadvantages of it? Now let's look at the advantage. The linear regression performs exceptionally well for linearly separable data. But the disadvantages, the assumption of linearity is between the independent and the dependent variables. That's a bigger assumption to have, isn't it? So linear regression is easy to implement, interpret, and efficient to train. That's the reason this has been taught to us during the school days. All you need is x and y of data, and then you will be able to draw a line based on the sum of the squares of the distance that we spoke about. And the moment you draw that, you are able to fit a new data in and find the corresponding output, which is going to give us better results, and that is what the prediction is all about. But the downside is it is often quite prone to noise and overfitting. What do you mean by overfitting? Overfitting means with the help of the data that is available to you to form the equation, there can be a scenario where you may be forming a perfect equation for the data that you have. Thereby, when you are going to bring in the new data in, it may not be able to predict the results correctly for the new data that is coming in. So the model is a overfit for the training data. That is the historical data that you have to build the model. Looking at the third advantage, it handles overfitting pretty well using dimensionality reduction techniques, regularization, cross-validation. So you understood the problem, that is the disadvantage of linear regression, that is it is prone to overfitting. But the good news is there is a solution available for it. So if you remember the types of machine learning algorithms, I would have spoken about regularization algorithms and dimensionality reduction techniques. That is, regularization is nothing but can I generalize the model that can be built with the help of the equation. So what kind of techniques I can apply there? That's where the regularization algorithm comes into picture. Dimensionality reduction is nothing but can I play around with the lesser number of features? By understanding the relationship between the features, can I understand how can I reduce the total features so that the overfitting can be avoided? All these things, techniques, the objective is very simple. You are trying to create a model which is generalized in nature, so that even when the new data comes in, you will be able to predict relatively lower accuracy fitness, but still this model can predict better accurate results for a larger set of data. Disadvantage of linear regression is it is sensitive to outliers. That is, if you don't remove the outliers correctly, this linear regression will be a problem. You can't fit the best fit line. Just imagine with too many points, if you don't remove the outliers, it will try to calculate the minimum squares and everything, and thereby the whole number will come out wrongly. And advantage, last advantage is, one more advantage is the extrapolation beyond a specific data set. That extrapolation is the key here. That is what makes the linear regression work. The disadvantage here is it is prone to multi-collinearity. That is, when you have x1, x2, x3, multiple number of variables acting as an input to the equation, there can be a problem when some of the variables are connected, like x1 and x2, x2 and x3. If they are connected, that is what is called as a collinearity. If multiple variables are collinear, then the problem is it is going to affect the model's accuracy. The equation may not be a perfect one. So these are the primary advantages and disadvantages of linear regression. So where can I apply linear regression? So let's look at some practical examples for it. As I told you earlier, you can predict the weather using the data set of the weather conditions in the past. So all the data variables x1, x2, x3 will be nothing but the data of the past, and it will tell you the variable y, which is the independent variable or the predictor variable, that is nothing but the temperature. Let's say, what is the temperature dependent on? So you will find humidity and all these factors which will be fed in as input, and you will try to look at the past data and form an equation to explain the relationship between the x variables and the y, which is nothing but the temperature of the day. This is how you apply linear regression. Economists also use AI to predict future market prices to make a profit. Even stock prices, sometimes they try to use linear regression, but of course you need large quantum of data to form a perfect fit of the equation. Otherwise it is really tough with a very limited data to get better accurate results. Doctors also use artificial intelligence to classify whether a tumor is malignant or benign. And the meteorologists use AI to predict the weather. HR recruiters use AI to check the resume of applicants to verify if the applicant meets the minimum criteria for the job. So again, if you look at it, it's all about pattern recognition. Are you able to identify the pattern of the data from the past? What is the insight that you are deriving from it? And can that insight help you to predict the future? So these are some of the practical applications of AI. And before I close the session on linear regression, I want you to understand that you can't extrapolate everything. And this is the best joke for it. Just because you got married once, you can't take that as a sample data set and say that, okay, every 30 years you are going to get married. That is not the right thing to extrapolate, right? So this is where the domain expertise comes into picture. A business knowledge of a particular problem will actually help you to identify when to extrapolate, when not to extrapolate. Okay? I hope you understood the concept of linear regression, the basic fundamental philosophy behind the linear regression algorithm, and now you know where it is practically getting applied. So if you have any questions, you can always contact us. Thank you very much for your time.